Uh, Brenda, can you tell us if we're too quiet? Right, we are now live, officially live. Um, so, hello. We're going to be talking about all things science. We're a bunch of PhD students at Lancaster University. You've probably seen my face if you've come on here before. You may probably haven't seen David or Izzy because I have many videos with them. So,
Mhm.
first things first, one thing I thought we could talk about is NASA recently announced a bunch of projects that they're funding, and they are very, very out there. We've been looking at this a little bit while we've been getting the live stream ready. Um, yeah, so I don't know. I guess I'll just go through the list and we can just talk about them as we go. So
Aye.
these 12 are like they're in the first phase of funding. They haven't been really funded at all, so they're still very early stages. So we've got the cryospheric Rydberg radar, which is a new type of quantum radar that could theoretically be used in virtually any setting. I don't know if you've seen
Theoretically be
radar.
using. Absolutely. Well, you're the expert on this one, I'm
I
afraid.
was going to say this is very
Yeah.
much your regime.
Yeah,
Yeah.
well, I did some work on radar stuff last year, and like I don't understand how that would work because like radar has a massive problem of like things like it doesn't work well in clouds because of like how much it gets reflected off of the clouds, um, and I don't know how you get around that unless you like,
Mm.
blow up a cloud.
Well, especially with quantum, at the moment, any quantum technology, the problem right now is the noise.
Mm.
You know,
So,
so like, and that's just from say your object that's trying to do your radar. It gets a bit hot. You're suddenly going to have tons of signal, which isn't actually um, like an object or something you're trying to detect. So I just don't even know how you overcome that with
It'll be
this.
interesting because obviously this is just the first stage. From what I can tell, this funding is basically we've got a vague idea. If you give us some funding, we can do the maths and hammer out something more sensible. So it'll be really interesting to see kind of where they go with this and what
Mm,
potential benefits and things could be.
yeah.
yeah.
Mm.
Next one we got is a silent solid state propulsion for advanced air mobility vehicles, which basically just sounds like some sort of quiet plane engine.
I mean, yeah, more stealth technology, I guess.
Well, yeah,
I guess in the long run could be beneficial for something like trying to bring back Concorde.
Yeah.
even just for people who live sort of near airfields and things.
Hmm.
Mm,
Like especially if you're living like right next to like a massive airport or something, noise pollution's a real problem. It like has like studies have shown like it massively disturbs things like your sleep and your health gets so much worse. So if they can make things quieter,
mhm.
amazing.
There is a novel approach they've done in I think it's an airport in I think it's an airport in the Netherlands, and Tom Scott, the famous YouTuber, he did a video about this, and it's that they've made the ground between the airstrip and the houses, they've made it all undulated. So it actually means that as the planes take off, these undulations absorb the sound, so it's much quieter by the time it gets to the houses. Um, so I don't know, but obviously it's better to put the quietness on the aircraft, but
But then
I think.
combining that with like so quieter aircraft with then these undulating sort of regions,
Mm,
sort of that's going to have a massive effect.
mm.
Do you know how effective the undulating stuff was? I don't
I
know.
mean, I think originally it was kind of a. I think it was almost set up as like a protest. It was like an art installation as a protest against the expansion of the runways, but it actually ended up kind of working. So it's now just been kept. So I think it's not like oh, it's now dead silent. You don't hear anything, but it is different enough that you don't have your house shaking when a plane tries to take off or anything like that. You know.
We got some solar sail stuff, uh, which is what Stephen Hawking was working on before he died. So he's
Hmm.
carrying that on.
Kind of uses would it use like the solar winds?
I think so. Like the one that Stephen Hawking was talking about was that it was so light that literally like, the particles from the sun could push it.
Oh wow.
Well, you get like the photons that will fly off of the sun if they hit anything, they transfer momentum to it.
Yeah.
So the idea is you've got to make one. Well, you've got to make like a sail, just like a sail ship back in like the 18th century or whatever. You've got to make a sail like that, which is going to get bombarded by the photons of the sun, and then if it's big enough, and light enough, it will just drag. So they, in their proposal though, they say, oh, it's going to be like super fast and like insanely quick. But the whole point of these solar sails is that they don't really take any energy, and they're very very slow accelerating. Like we're talking zero point 0.2 meters per second, you know, and it's just as they travel over years, they really get up to like, you know, not close to the speed of light, but they get up like, you know, to maybe 0.2 c or something like that, or zero point 0.2 times the speed of light. So,
So the current record holder is 3.6 AU per year, so like can do the journey between Earth and the Sun 3.6 times in a year.
hmm.
But obviously, if we want to explore anything really sort of beyond Neptune, like in any form of detail, we really need those like sort of faster technology.
Yeah. And it does make me think, like, because obviously Voyager 1 and 2 are now leaving the solar system. Like, how fast are they going? Because they've just been.
So Voyager 1's the record holder at
Right.
3.6.
Right.
But so an Ob-Earth maneuver, from what I remember, it kind of, the spacecraft will like sort of direct itself to an area of like sort of very low gravity, but then this looks like it says it's going to like then propel itself through that to kind of build up the speed, so kind of like a gravity assist, but not quite.
But with just kind of low, like as in areas where the net gravity is very low.
Yeah.
So it's almost like falling into it, and then it's gonna like, yeah, okay, fair enough.
Through the power of the sun.
Yeah. Yeah.
Yeah, and then we also got a couple of like spacesuit designs, oxygen atmosphere machines for breathing, um, an asteroid destroyer, which I don't really get how that's going to work at all.
I know. I feel like isn't there like a Futurama episode where they just learn that like the best way to do it is to just hit it with like, no, it's the rubbish that's flying back to Earth, and they just hit it.
Far another
Yeah.
rubbish at it.
Yeah. Yeah, because obviously the main problem with say sending a nuke up and then destroying an asteroid like that is rather than actually stopping it hitting Earth, you've just split it up into thousands of pieces that are now going to rain down on us. So this
but
looks.
Pieces are then small enough that they burn up in the atmosphere. That solves the problem.
Yeah, and they're using. This one will be a hypervelocity kinetic penetrator that will pulverize and disassemble an asteroid or small comet. So yeah, so they're like, rather they'll just shatter it, rather than a nuke will hit it and either could just blow off a little bit of it, or could just deflect it back into Earth and not really like break it up. Oh, and they've even got like timings on this, where it's like mitigation of a 1 kilometer threat would require a 60-day intercept to make it done. So that, you know, it's really something. Like they've really thought about it, you know.
And we got a what's it called? In situ neutral optics. Basically some words that stand for innovate. Spacecraft swarm used to study space weather, so they'll be looking for solar flares and stuff like that. Um, which is a great idea because we need to be like more aware of solar flares and stuff. But the second there's a solar flare, it's going to knock all of those out, and they'll be useless.
Yeah.
However, I would like to congratulate them on having an astronomical acronym that actually works.
Yeah, that isn't something ridiculous / all of the capital letters have to be in the words or something.
Mayonnaise, I'm looking at you.
Yeah. Yeah. But I think this is good because there is this whole drive now to really kind of have these early warning systems for, say, solar flares. Because I think people think, oh, solar flare happens, and it's like, oh, we have, you know, minutes before it strikes the Earth, which isn't really true. Like we would have like a couple of days to prepare or insulate systems. So I think that the last time we got hit by a major solar flare was just at the start of kind of the Industrial Revolution. It was sort of in the 1820s, and it was actually seen by this British astronomer called Richard Carrington, and he was sort of the guy who discovered what solar flares were. But you were talking like transmitters and stuff on the Earth, like burnt and like, you know, exploded on operators and stuff and really injured people. But then on the plus side of it, if you were a sailor going around the equator, you got some aurora, you know.
Yeah.
So there's pros and cons, maybe.
Everything's but at least the sky is pretty.
Yeah, but it is like in the modern day, we need to be able to see these things coming, and even like a couple of hours notice would probably, I suppose you can't really insulate a power grid in a couple of hours, but you could at least be like, maybe everyone leave the power grid station before it blows up.
What would
You know?
happen if you shut it down? Sort of temporarily turn everything off.
Oh, that's true, actually. Yeah, it would just
Like
because
old
you wouldn't get the overload.
Yeah.
Yeah.
With old-fashioned TVs, in a lightning storm, you'd have to turn them off.
Mm.
Kind of a more extreme version of that, and it's better to go without power for a couple hours than have everything destroyed.
Yeah. Yeah, yeah. Or I'd say like get overloaded and blow up.
Mm.
Yes, there's 5 projects that they've announced that are getting a second round of funding. So they've already been through the first phase, and now NASA's been like, "Yep, okay, we're cool with those. Let's keep going." We've got a bird-like drone to study Venus's atmosphere and weather patterns, which interesting.
Yes, they can like sort of looking at natural things and how they fly and applying it to technology.
Mm.
Just so
And I guess,
Biology meets engineering, you know?
yeah, I guess for something like Venus as well, like, that's the only way to like really explore it because like the surface, like we were talking about this a little bit before, but like how the rovers really struggle on the surface because it's so hot and there's such high pressure that like, so I think the surface of Venus is the exact melting point of solder, so like,
Mm.
most things don't survive on Venus very well.
still crispy.
Yeah.
Yeah. Yeah.
There's also a proposal that's got on this funding as well. So these ones, so the original ones we mentioned before, they get $175,000 over 9 months. These ones have been awarded $600,000 over a 2-year period. Um, so we've got a kilometer scale space structure from a single launch, and it's going to be a rotating space habitat with artificial gravity.
Mm.
I don't know if either of you have seen The 100, the TV show, but their design on that, which creates its own artificial gravity, looks remarkably similar to this, which is really cool.
Binge watching.
I really hope it is, but I'd expect the design for this one came first, not the one for the TV show.
Yeah. I think it follows because does it do it by rotating, and it's then centrifugal forces that then push you as if it's artificial gravity. Yeah.
Yeah.
Because they have that in like The Martian and stuff like that. I think this is.
If only there had been like some sort of science fiction author who'd had that idea first.
Yeah. Arthur C. Clarke. No.
Amongst those other inventions that he did because he was just an
Yeah.
absolute genius.
In one of his books, there is I think it's in 2010, A Space Odyssey, which is the sequel to 2001, A Space Odyssey. They go back to Europa in order to find like, oh, what happens to the main character of 2001, and the guy goes there, and a beetle crawls out of a cave on Europa, and then kind of eats him. So he's been right about a lot of things. This could be the next big one. Just saying. But yeah, about the like we kind of need different space stations now. I think that NASA's saying they're going to be crashing the International Space Station into Earth in 2031, and it's really going to give way to commercial, commercial space stations, which I'm sure we all have opinions about. But whether we like it or not, it seems to be like commercialization. Unfortunately, seems to be the way that space exploration and space habitation are going. So
Commercialization does bring money,
I mean,
even if nothing else.
but you think it should be more than that, shouldn't it?
Oh, it should be. Really
But,
should.
Yeah.
And then what else we got? We've got a nuclear power for spacecraft. I mean, that's going to happen anyway because we need more power in our spacecrafts. ReachBot, a small spelunking robot designed to explore subsurface caves on Mars. So that would tie in with the what's it called? There's one that's on Mars at the moment that's using asteroids that crash into Mars to look for subsurface caves. Because the theory is that if there's life on Mars, the only place it can exist is in caves because it's the only place that'd be warm enough and be shielded from radiation.
Hmm.
Yeah, because obviously Mars, because Mars is lacking a magnetic field, it's much more susceptible to like the damaging effects of the sun than any planet with a magnetic field like Earth.
Yeah.
So I guess that would then follow up on any caves they then find. And I guess as well, they're probably planning it for, I don't know, like any other rocky planets, like if they want to do like more in-depth explorations of like Venus or something or the moon.
Yeah. But then I don't know. I don't know how I feel about that one. I'm a bit questioning of the point of it, but fair enough. I think the whole life on Mars thing is a bit of a hot topic at the moment, but I don't give much credence to it. I don't think.
But five, oh sorry, Jamie, you go.
That's right, you go.
So all of these 5 projects seem like they're very transferable and have like multiple uses, which I think is really good. So even if you're not keen on using it on Mars, maybe we could take it somewhere else, Rocky.
I mean, even just spelunking, having these kind of robots that can spelunk on like caves on Earth, like that would probably be really good, you know. And yeah, the ability to do it on Mars would be cool. Like, don't get me wrong, it would be awesome. But I'm like, there are definitely some other things that I'm like, I think that should be funded first before we fund something like this one. Yeah.
Well, because in the same vein, there's the last one that's a swarm of 3D printed swimming micro robots that can explore ocean worlds like Enceladus, Europa, and Titan.
Well, this is where I'm gonna really hamstring myself and go, no, I really want this one.
Robots to Europa.
Yeah.
I mean, yeah. Yeah, like ocean worlds are a thing that we've never explored something like that.
But they're also such great candidates for life. Like, it's been theorized that life on Earth started in oceans. So if you take these ocean planets, maybe, like, we don't know, like David says, we haven't really been there enough. So maybe with these little microbots, we might find evidence to the contrary of life.
And I mean, the way to find out, just have them basically be a rover. They're just going to swim for like 2 or 3 years, and in the kind of infographic they have, it's track heating gradients. So what that means is they will start in a cold place and they will always move towards the hottest area they can find, and that's again. Life on Earth might have probably started at a heating vent somewhere under the ocean, so it's the place they need to go in order to maybe find those origins.
Yeah, so there's a lot of weird and kind of out there science. I think especially the Venus one's interesting. Like there definitely seems like a reaction to the discovery last year of phosphine.
Yeah. Well, and that's really taken off. I think kind of for the wrong reasons. Well, like so, phosphine is this molecule that exists here on Earth, but the only way we know that it's produced right now is by life. Like it is a byproduct of life existing and kind of creating it. It can get formed, I think, at like planet's creation and stuff. But then the fact that then there's more of it seemingly being created on Venus means that something is generating it, and we don't know what that generation is. Now, I'm already excited about that just as a thing of there's this weird process that must exist on Venus which produces phosphine and then puts it there. But everyone's really been taken away again by the whole life on Venus thing, and I worry that looking at it in such a way like that can not take away, but it makes, I wonder if it makes the science harder to take seriously when people start going, oh, this must be a sign of life there, you know.
Yeah, but then it's also. Oh, sorry, go on, Izzy.
Even if we just find like a new chemical pathway of making this molecule, that is still super cool science.
Mm-hmm.
It just isn't the big headline science necessarily of life.
Mm-hmm. Mm-hmm. Which unfortunately is what, well, I remember at the announcement is not quite what NASA led with, but it was that the first science team was going, oh, so we've discovered this particle, this is really interesting, could be other things, and then they were really pushed into going, oh, could life be one of the things that created this? And they were really pushed into being like, well, yes, it could be, but it's probably not. And then everyone was like, oh, that means there's life on Venus, you know.
But like, unfortunately, like that's how like funding gets like applied.
Yeah.
Look at all the funding that's been now attracted into like the space industry because of SpaceX. It's like
Yeah.
kind of popular like does attract the most funding.
And I suppose I'm complaining about nothing because we do need to go there and check it out and figure out what it is. And if it was life, it would be amazing. But I honestly really don't think that it is, of course, otherwise I wouldn't be saying all those things. So in a way, I'm like, if this is what we need to do to get funded, then I suppose we do need to play the game, don't we?
Either way, there's going to be some super cool science coming out of it.
Yeah. Well, actually, remember, well, I don't know if you guys have seen, but there's a lot of literature coming out recently about whether or not they even detected phosphine at all. Like it's really been put under scrutiny, whether or not it actually is there or not. So this will solve that as well.
So what makes them think it might be either phosphine or not phosphine? Like what's the process behind
it? The problem is that what wasn't surprising about finding the phosphine, sorry, that's not what was like surprising about it was finding it there. What was surprising was how much of it there was. So I'd say at early stages in the planet formation stuff, some amount of phosphine should be made, and then that should kind of be there sort of forever, and it shouldn't increase, it shouldn't really decrease, well, unless like other stuff happens. But then, they've run very clever models of Venus that say this is the amount of phosphine that should still be there at this point in time. But what they've then gone and measured is actually no, there's some ridiculous 20 times more phosphine on Venus than originally modeled and originally thought, which therefore means something must be producing it. But a lot of other people have kind of gone back to the maths that the original team did and gone, actually your maths is wrong. When we look at your numbers and apply correct maths, we get the right amount of phosphine, which means that nothing's creating it. It's fine. But then the original team is a very, very, very good team. They're kind of renowned in astronomy for what they do. So they've doubled down and gone, we didn't get anything wrong. We've measured the right amount of phosphine here, and there's too much of it, so something's creating it. So the only way we solve it without more maths, more terrifying maths, is we go there, measure it directly.
But yeah, there was also another one of NASA's potential new missions is essentially send something to Venus that then returns here, but has collected a bit of Venus's atmosphere. So that would probably provide far more reliable estimates of the amount of phosphine in the atmosphere.
Have we done anything like that before?
One will be China's missions at the moment to bring back moon rocks.
Right.
They're sending up. They're doing it in I think they're on stage 4 at the moment, where the rover is collecting rock samples, and then the next stage is then send up another rover to go pick up that rover. But we haven't really done any retrieval missions yet.
No, because was there something with there was one with a comet, but then I can't remember if it failed, and that's why I didn't say. I was just couldn't remember. But anyway, so if that could work, I mean, that would be amazing. A bit of Venus back here,
like in a little gas bottle somewhere, like Venus.
No, it's a little Tupperware, a little a little lunchbox of Venus.
Get your takeaway Venus.
Because we've managed to get that with we've managed to get that with Mars. So bits of Mars have rained down on Earth before. So you can kind of look at the composition of some meteorites and you realize, this is what's actually happened is another meteorite's come in and struck Mars. A bit's then flown off of Mars, which is then, very, very most impossibly then come through and then landed on Earth, which is how we have a bit of Mars here. But I don't think that's ever happened with Venus. So, or at least not that I have ever read.
Right, let's move on. If either of you have seen this news this week about the fact that the T-Rex might actually be 3 different dinosaurs.
My favourite thing here is the names they've chosen for the 2 new potential versions or species of Tyrannosaurus. So obviously, the original one is Tyrannosaurus Rex. The way of dividing it into 3 is keeping Tyrannosaurus Rex and then having Tyrannosaurus Regina, which translates to Tyrant Lizard Queen, and Tyrannosaurus Imperator, which is Tyrant Lizard Emperor. And I'm loving the theme they've taken here. It's
just in case you haven't seen it, basically what they think is that all our fossils of T-Rexes are actually 3 different T-Rexes. They think the T-Rex is the parent one, and then these 2 new ones are like evolutions, sub-evolutions of it. and almost like children, but over like thousands of years. So they're very similar but slightly different.
Mhm.
I had a very quick sort of look at the article. It seems to indicate that it primarily looks like thigh bones and teeth.
Right.
Um, and these sort of show like enough differences. And they also, so something like the split was like 2/3 was this one type of thigh bone, and 1/3 was another type of thigh bone. And if it was based on whether or not the original dinosaur was male or female, we'd expect more of a 50-50 split. So they're using the fact that it was this kind of 2/3 to 1/3 ratio as evidence that it's like not a split based on the sex of the dinosaur.
Mhm. A kind of comment I saw, and I think it might have been in the same article or a different article, was that some of the discussion or some of the like kind of fight back against it has been actually that it's not that the T-Rex is three different species. It's actually that these other two, the Regina and I forget the other one that you just said, that these two, yeah, are actually further along evolutions of the T-Rex. So the T-Rex is like up here, and then you have these diverging species that then come off and are these two, which I think is quite cool, but also I have no idea how you would prove that. I mean, I don't know much about paleontology, but um, like, unless you actually could separate, because by the sounds of it, the differences are so minor that we've not noticed up until now. Then how would you know if you had, like, say, a full skeleton of one of these sort of um, descendants of the T-Rex compared to not, and then prove that they existed at different time, like at totally different times and like evolutionary different times. Um, but it seems to have caused a bit of an uproar. A lot of people also don't quite believe it, you know.
An uproar.
Yeah. See. Yeah.
Yeah, the thing I wonder is like how much things like the Bone Wars have like massively slowed this down. Like if so I know there's
Mm.
just in the Bone Wars, and it's just
Mm.
yeah, I wonder how much that might have if it hadn't been for that, like this would have happened much faster.
Yeah. So if you don't know, the Bone Wars was this war, inverted commas, between these two paleontologists back in the early 1800s, where I forget. I think they used to work together, and they just had a falling out about something, and they just went, I am going to, humiliate you in the academic circle. I am, and the way they tried to do this was by just discovering more dinosaurs than the other, and if you get the opportunity to read about it, I would recommend it, because there's points where like one of the two of them would send out a team to go and mine some dinosaur bones out, and the other guy would send like a lawyer along to just be like, hey, I can give you a ton more money than this other guy. You should totally just mine these bones for me. And then like the teams would be swapping sides. There was like people like breaking into stately homes in order to just steal bones and stuff. Um, and it just turned into this huge mess where but by the end of it, 136 new dinosaurs have been discovered, one of which was the Stegosaurus. And that was, I can't remember which one of the two. Hang on, I'll see if I can find their names actually, because yeah, between these two men called Othniel Charles Marsh and Edward Drinker Cope. So I think it was Marsh kind of discovered the Stegosaurus, which is then what we kind of remember most. So I think people kind of consider him as the winner of it, because his like legacy went on. But the fallout of this was then, as more paleontologists got involved, they kind of realized, no, hang on a second, a lot of these 136 dinosaurs that the two of you claim to have like discovered and fought over, these aren't real. They're just bones you've thrown together and stuff, and like your hastes outdo each other. Um, and it really, as it really got to a point where you had these entire skeletons, which then, I don't know, it would be like a T-Rex skeleton with um like a Stegosaurus bone, like leg bone or something, because they were just like, no, we need to, I need to be able to say I have found the first full T-Rex skeleton, as an example. I don't think that actually happened, but
So
yeah. But and that's that the problem is that's how paleontology was done back then. So we it started off as this race for glory kind of thing, and then became the science we know it as today. And I think you are right, that really has kind of held it back a little bit, where these little differences in bones and stuff like that, we won't notice, because it's all mixed up and muddled up.
Yeah, because my understanding as well is like they would literally just like grab some bones and be like, "Oh, just shove them all in a box. It doesn't matter what they are. We'll figure it out later." So it was chances are they could have been like a perfect one of these new T-Rex skeletons laid out, and they were like, "Oh, we need that for our other T-Rex skeleton. Just take the legs and leave the rest of it behind or something."
Because
Wow.
we've got to get back and publish it now. Like you know the other guy knows about this and he's going to publish first, so we've got to get back and publish now. Yeah. So
Imagine how much more we'd know about dinosaurs if they just worked together and shared credit.
I know I just very quickly jumped on the Wikipedia page just to be like, why did they fall out? But it is something. It is just something so small. Oh
When
yes, it
this
was.
like fairly new after sort of the existence of dinosaurs was first sort of discovered, theorized. I'm not sure of the right sort of terminology, but like
Yeah, like we kind of like only just realized that dinosaurs actually existed
And yeah, took an interest in them.
because I think
often that
George Washington wasn't alive when we knew about the existence of dinosaurs.
yes. No, that makes me really sad that he never got to experience the wonders of dinosaurs. It makes me really sad.
But no, I do want to just quickly read this. The reason they had this falling out was because Marsh humiliated Cope by pointing out that his reconstruction of the pliosaur was flawed, and that was then for the rest of their lives. They were never going to work together again.
So pettiness. It comes down to pettiness.
Yeah, with where the head was placed where the tail should have been. That was how flawed it was.
Oh my god, it's like the bones of cat dog or something. Yeah. That kid's cartoon creature with like the cat on one end and a dog on the other.
Yeah.
That's
So
next level spite.
you know, imagine like that doesn't. I hope that doesn't happen anymore. Where someone just goes, "I'm going to dedicate my life to just destroying you," and then the other person goes, "No, I'm going to dedicate my life to destroying you," and then it's just hatred.
Like Isabel, one of the lecturers in our department, she was part of one of the Nobel Prize winning teams for looking at supernova, and they were actually a giant team of like 50 people, and they split into two different teams because there was two rival theories, and it was kind of like whichever team got the discovery first was like, okay, you've got it, but they were actually the same team, so they were competing against each other, but they still kept it very civil because they were like, both had the same goals, they knew each other, they were all friends, like they'd all been to university together and stuff like that, so it was much more civil than like this stuff with the Bone Wars.
Hmm. I think that's almost sort of competition, which is spurring each other on, and you're finding science that way, rather than competition that is, I'm going to make stuff up to be ahead of you. You know.
I
Yeah,
think there's a lot to be said for healthy competition in science because obviously wanting to find that new discovery really does kind of help us to push the boundaries and stuff. As long as it's a real discovery and not I stuck a Stegosaurus bone in a Tyrannosaurus Rex bone.
Yeah. New dinosaur. Easy.
yeah.
How to make it
Like the Americans and the Russians with the space race, like if they've been out there sabotaging each other, like it would be very different from what it was. But like they did keep separate from each other, really.
Hmm. I mean, I think that's definitely a conversation for another time. But I have a feeling they probably did try to sabotage each other quite a lot back then. But then it was also separate and everything was so secret as well in the Cold War. But yeah, we should definitely talk about that sometime.
All right, then changing gears then for a slightly different evolutionary topic. So, have you heard this theory that everything tends to be crabs?
everything tends to crabs is one of the best evolutionary theories, at least just for the name. It's so the technical term is carcinization, which is much more boring. But from what I can tell, it's basically this theory that most crustaceans, like they all had like a very similar common ancestor, and then they kind of split into these like two paths. One of or not two paths, but many. One of which would have been like crabs as we know them. Um, but all these other paths keep seeming to evolve back to crabs, which means you have things like true crabs, such as things like the Japanese spider crab, which is like 4 meters long, down to like tiny little ones. But you also have like fake crabs, such as the king crab, which their last common ancestor didn't share any of the physical traits that would identify them both today as crabs, which means these two traits have evolved separately, or the same trait has evolved twice. But this appears in so many more places, known as convergent evolution. And you see it in things like, so for example, humans, when they see things, we have 3 different colors that we see, red, green, and blue. And the combination of that makes up the colors that we see. Obviously, it's different if you're colorblind or anything like that. But this has also evolved separately in other different species of animals. So different animals have different numbers of what we call cones. So dogs have 2, which are green and blue. You've got things like there's a type of shrimp that's got like 16, which is insane.
Manta shrimp.
That's the one. I want to know what colors they can see. But this these red, green, blue vision also appears in like a couple of types of monkeys. But our last common ancestor with those monkeys didn't share the same vision that we do. So this whole convergent evolution thing is just really cool. And like hedgehogs and porcupines, their last common ancestor wasn't spiky, but they've evolved spikes separately in this really similar way. And it's almost kind of like evolution took a sort of turn, went, nope, that doesn't work, I'm coming back to the original.
Is it like with like crabs and stuff? Is it just that like things like they realize like a hard shell and claws are like such a like powerful combination?
Partially that. So it's theorized that convergent evolution is due to sort of inhabiting the same space means you do need very similar traits, particularly if you share things like a diet. So carcinization, the 3 things they focus on are the carapace, which is what's now the crab's shell, is kind of flatter than it is like broad. So you can see in other types of crustaceans, they're now starting to develop this carapace, which is kind of like the top. If you think about a crustacean, it's kind of got like bits with, I don't know how else to explain it. I'm not a biologist. That kind of look like mini shells, and the top one is the carapace that's now become this sort of big thing. There's also a sterno, I think it is, that's kind of evolved into what the crab knows as its gill, and this has evolved several separate times. And the other one is the pleon, which basically means the carapace, its shell, is right up close to its head and not sort of further down its body. So these are the 3 things that are needed for like carcinization. Everything tends to crab. And yeah, it's been observed in like 5 or 6 different groups at least. So yeah, they just tend towards this shape because it clearly works well.
So I guess this is kind of like a difficult question. I don't know if you know the answer to this. Is there any like theories of like other convergences that could potentially happen that we haven't seen yet?
I'm not sure, to be honest. It'd probably be quite difficult to imagine which evolutionary traits are working until you see them. Like it's very difficult to kind of look at, well, for me at least, obviously, like I say, not a biologist, to look at a species and go, yes, this bit of it is useless and will sort of become obsolete in a few million years. You can see it in some places with humans. So some humans have like a tiny little hole sort of just in front of their ears that is our gills sort of evolving out. But the gene is still there. It's just a very recessive gene, which means you need both parents to have it in order that you can inherit it. Because it is now sort of, I suppose defunct is the word. So yeah, that's one that's fading out quite quickly.
I wonder, I was going to take this just totally kind of crazy mode, and go like, well, does that mean that there could be something that's like kind of carcinization, like, but for say like intelligent life? Because I was thinking, you know, obviously we like intelligent life in the sense of like sentient human. We have one species, which you can't then be like, oh, let's start drawing parallels. But like, say, a very important point in humans' evolution was when we had thumbs and then started picking up tools, and then that's how that then kind of massively projected us towards becoming like sentient and where we are today. So I just wonder then, I wonder if there's something like when we do meet a bunch of aliens or whatever, or if we ever do, there'll be like, will every alien have a thumb, or is there an optimum? Is there an optimum look that an alien like that intelligent species will have? You know?
So kind of that maybe sort of bipedal walking on two legs thing.
Yeah, well, potentially, yeah.
As only our feet can evolve to support us walking on legs. Human feet are badly evolved, I maintain. They're too flexible to be able to be sturdy enough to walk on, but they're not flexible enough to do anything useful with.
You saying that the shoe has ruined our evolutionary tract with feet?
I don't think shoes have been around long enough to ruin
No,
it.
yeah, no, I don't think so either.
We
Yeah.
should have hooves, I maintain.
No, that's no. You know.
Like twist your ankle and you just get shot.
And it's only if you've got like 4 of them. We've only got 2. We'll be fine. We'll learn to hop on one hoof.
So not centaurs, sorry, what they call fawns are the optimum. That's it. That's the carcinization of humans.
I really hope so.
No, I really hope not.
We missed the
No, that film was awful. Please, no.
Fate is, I think it
Yeah.
as well. Yeah. Oh,
That's
so
really, I never knew anything about this carcinization thing, but I suppose it makes sense because they're just if there's just a trait that means you survive better. I mean, that's how evolution like works. Is if you know you're more likely to live, therefore you know you'll keep that trait and that you'll keep that trait going. Yeah, it just makes total sense. You know that such a thing like exists.
Yeah, if you read like science fiction stuff that goes like deep into like biodiversity and stuff, especially about like life on alien worlds and stuff, they normally bring up this whole like everything is crabs, and they will have be like, oh yeah, on this planet everything is moths because there's like very like light atmosphere or something, and it comes up a lot in science fiction.
But then you couldn't be like, because I don't think a crab. I think if you gave a crab 1 trillion years, I don't think a crab would. Well, maybe it would. Do you think a crab could evolve to like human levels? Sorry, we're getting way out there. We're getting way out there now.
wise.
Well,
Or
no, because I was like, you know, there were certain traits about humans as they evolved that meant that it like projected them on that path towards it like sentience. So like, so for example, like the thumb, or, well, that's the only example I can think of right now.
the other big one.
What? Sorry.
Like brain size.
Yeah, like brain mass compared to
Mass.
yeah, compared to body and stuff. So then does that mean that like, you know, does carcinization in the way you just put it, where it's like everything becomes crabs? Does that mean that then there will never be intelligent life on that planet, potentially?
Don't know, you could have a super crab. Well, because the one that's supposed to be the furthest along the evolutionary process is certain species of crows are supposed to be like insanely smart, and like there's some now that can make their own tools.
Ah,
But obviously they don't have thumbs; they use their beaks to do it.
yeah.
They did
So
that experiment with the crows where they had 2 crows and 2 kind of sort of milk bottle shaped things with like a chunk of crow food in the bottom. I think they like meat. I don't know, but I'm gonna just call it crow food for now. And they also had 2 metal sticks, and one was straight and one was like bent at the end. And it turned out you need the straight stick to get the food. And so when they first like released these 2 crows, each crow picked up one stick and tried to get it out, and the crow who picked up the straight stick got the food out quicker. So then they repeated the experiment, and they expected the crows to fight over the straight stick, but they both immediately flew to the like one with the bend in it and helped each other straighten it out so that they could then both access it, which is so wholesome.
And so smart, like, yeah. Because because there is things where like crows, they can make sounds that are approximate to like say, because there was that video that went around ages ago of the crow that went hello, and stuff like that. Yeah, so it's just awesome.
We'll leave it there for today. We've been chatting for like 50 minutes or so.
Yeah.
Yeah,
So thank you both for coming on.
no
Thank
worries.
you very much.
Thank
Thank
you.
you.
If anyone is watching, I don't know, Brenda took the iPad upstairs. But if you're watching, thank you very much. We will probably be back at some point. Don't know when. We figure that out. This is a trial run for us. So if you have suggestions, feel free to let us know. Um, but yeah, if not, in some point in the future, we'll be back with another episode. So we'll see you then. Bye.
Right.